Okay, so what you see here is the topic that I'm going to talk about. Is my data okay? A guided to evaluating CTD data. And the idea behind is to say, as soon as I collect data, I have to think about, is it everything working fine or not? Is an issue with an instrument, or are these all real data that I'm collecting? Okay, and that's the main topic. And what you see here on the left-hand side, I thought if we are part of this marine beer event, I show you a very good beer that I typically drink in Germany in my favorite bar. And that's what I wanted to show you here.
What's it called, the beer?
So to get started, I want to cite something from a keynote address, and please look at the date, January 22nd to 26th, 1968. And what that means, it's almost 6 years, 56 or 55 years old. And what is written here is the determination of the true accuracy of oceanographic information becoming a complex problem where standard techniques of calibration are needed. This is original citation. And that means people were aware at that time that there is an issue and that has to be addressed, but it hasn't been really done within the past 50 years or 55 years. And that's, I think, a major issue that people have to address. So ocean technology is still struggling with the broad implementation of standards. And so I would like to come back to when I first got in touch with Dustin, because he was a person who was pushing for a new ISO standard, the 22013. And that was actually the first time that I became aware that people are getting serious on this standard. Don't be surprised that this slide is going back and forth. This is, again, an issue of the format that I was sort of working on. Sorry for that. And the question is, will this change within the next years? And I think one can be optimistic, and that has something to do with the complexity of the system parts that are addressed. For example, Ocean Network Canada. I think there's a real need to think more about standard operating procedures, standards, best practices, so to say, is already a topic that people are thinking about. Okay, so let's go back to think about how we achieve trustworthy data. And so we have to ensure the quality, and I think everyone who is now listening knows what to do. So if we want to deploy an instrument, a CTD, we want to make sure that it's properly checked before the measuring campaign starts. And that means we do some basic functional tests. We do this check of calibration status. We do a final test before the actual deployment. And if possible, we also do some checks, for instance, for signal noise, outliers, so during or after or immediately after the deployment. Okay, and what I would like to focus on is what is underlined here in red, is the post-deployment analysis of collected data. And because from there, one gets the final clue to judge on the quality or whether the data that we are collecting are okay or not. Okay, so how will the measuring has the measuring campaign designed that I wanted to talk about? So we formed a group within Germany consisting of different institutions like Alfred Wegener Institute, the former Coastal Research Institute called GKSS, now it's HEREAM, and the Institute of Baltic Research, and also our standard office had been involved in that. So all these people were contributing to this measuring campaign, and a publication actually came out of that. I can give you a link to that publication later on. And the base was just an intercomparison experiment with CTDs from different manufacturers. It was also important not just to focus on one specific. We wanted to find out about the influence of the methods on the instruments. So all CTDs were calibrated at the same time and then deployed. We were using a calibration facility in Germany. There's one in Rostock, which is the eastern part of Germany. And from my point of view, they have the best calibration facilities here in Germany. And therefore, I think that's the best place to go and carry out this calibration. I also would like to emphasize they have an accreditation by our standard office. And many people in other countries say, we don't want this or we don't need this. But they went along this route. And then I think there are some advantages, because in that case, if you do that, you have to follow the guidelines coming from more or less the GAM. You know, you have to specify the uncertainty. And that's a specific aspect why people should consider to have this accreditation. So data were collected in real time to check for any major issues. As I mentioned before, there's always a good chance to look at the data. We also did regular drift checks, and we've done this by recalibrating instruments and redeploying it, or taking water samples, both of them. And the overall deployment time was about 4 months. So we get a good chunk of data, and we actually covered different seasons. So in summer, it's a coastal station that we're using. We have a lot of fluctuation in the signal, and in fall, it's calming down. So we have much more stable conditions. Okay, the purpose of a campaign was actually to look into quantifying the uncertainty of salinity and temperature. That's for sure. I missed to say that here. And what we wanted to do is identify individual contributions to an overall uncertainty budget, because uncertainty is not just derived from a single parameter or single number, but actually it's summed up from different contributions. I show some examples later on. And we also wanted to check for specific influences on temperature and salinity measurements by the deployment configuration. More or less, say, what's the contribution coming from the field conditions on uncertainties in the measurement. Okay, so this is where we deployed our instrument. Aha. No more text in the background. I'm happy. Okay. This is the deployment location. I'm not sure whether you know Germany good enough, but we just have a very short coastline, a little bit in the North Sea, and a little bit in the Baltic Sea, and I'm talking about the North Sea, so to say northwest, and so to say right in the middle of the German Bight is the island of Helgoland. And they have an underwater node there. So we have a cable system, not similar to Oceanographic Canada. It's on a much smaller scale. It's just a few 100-meter long cable. And that's it. And also the data management part is not that developed compared to Oceanographic Canada. But in any case, so it's an opportunity for us to do such type of measuring campaigns, and we used it for that. Okay, that's how the configuration looked like. And if you check it more closely, you see the distance between the individual instruments were 15 centimeters. So we wanted to have it as close as possible. Then we thought a lot about the height above the seafloor. So we decided something of the order of 1 meter. And actually, my suggestion was to go even higher, but there are actually very strong currents in this region. So that would be it could happen that this is simply pushed over. So we didn't want to have that. So that's the reason why we end up with a height above seafloor of 1 meter. And the overall deployment depth is 12 meters, which is not that much, but in any case, we just sort of say, took what we got, more or less. And this is a picture showing the same configuration taken by a diver. And that was also a very special situation that we have, because they have a diving group, and one of our partners is leading this diving group. And that means as soon as something goes wrong, someone can go there, replace the instrument or repair the cable. So that was very convenient for us, because we didn't want to lose or have major data gaps. This is always difficult then to evaluate the data properly. All right, I mentioned the calibrations already. And first of all, I hope you can see, or you all can see what is shown here. This is just the result of the temperature calibration. You have a calibration bath where you control the temperature, and we had it control between 0 and 30 degrees centigrade. And what you see on the y-axis is the difference between the reference temperature and the sensor temperature. And so blue dots is when the sensor came in, so it was calibrated with the old calibration coefficient, and the red dots is after the calibration, so when you adjusted the calibration coefficient. And what you can see here is actually that looks very good. You would say, okay, the uncertainty is something of the order millikelvin, maybe even better. And just to tell you that we can start a discussion on that. In the end, the uncertainty of calibration is worse than that. And I know some people like Siebert would not be happy to enter this type of discussion, but the issue is that the reference instruments are actually not that accurate. In particular, outside the triple point or the gallium point at 28 degrees centigrade. These are well specified, but everything in between is probably not better than 2 or 3 millikelvin. So the absolute temperature is actually worse. So the absolute uncertainty, or the absolute temperature value, you have to expect an uncertainty of the order of 3 or 4 millikelvin. So I know this is something that needs some more explanation, discussion, but if you like, we can enter this later on. Okay, that was one aspect, but as soon as you look at the temperature data, I haven't shown any slide here, but just trust me, the data look perfect. You know, they are in this band of millikelvin, the temperature are matching. But there's, in some cases, there are major differences in temperature, even under the conditions that these CTDs are very close to each other. And this is always the case if you have higher fluctuation of the signal. And this is here shows a very short time frame, 30 minutes on August 6th. And I can tell you that was a day where there was lots of sunshine. So surface water was heating up, and due to tide, it was mixed into deeper layers. And that means you have a lot of turbulent mixing also going on. And that leads to these high fluctuations. And now I come to QA/QC. If someone says, okay, QC means for me 3 times the standard deviation is an outlier, you will probably end up with a certain number. Here in this case, it was, maybe barely see it, 166 for this time frame. But you know, if you go to say 3.5 or 2.5, this number will change. And in some cases, you might wonder whether these are really outliers or whether they should be still included. For instance, look at this part. If you see my pointer here, if it's suddenly going down steeply, you suddenly have some outliers which actually are part of the signal. So this is an issue that you have with QC, in particular if you have highly dynamic conditions. So we looked into all that details and were a little bit confused and didn't know how a good answer can be provided. Maybe you have ideas or you have thought on this as well. Anyway, okay, let's come now to uncertainty budget calculations. And I would like to emphasize the term budget because, uncertainty is not just, okay, I look a number up that the manufacturer is providing. That's sometimes happening. People say, okay, we talk about uncertainty. I take the accuracy that the manufacturer like Seabird or any other company has provided. This, sorry, not correct. In the end, you have to include other aspects as well. And here are, for instance, for salinity, or it's the same for temperature, actually. You have to sum it up in that way. Say, okay, you have the calibration uncertainties. You have some sort of drift characteristics. You may have pressure dependence. You have a digitization uncertainty. Then, if you do not know the exact time, and typically you assign your measurement to a time spot, so you have to include that and so on. You can add up to, let's say, 10 or 15 or 20 different contributions. Typically, most of them are negligible. So there are only a few components that you have to take into account. But as soon as you talk about such type of consideration, people say, yeah, how shall I know about all these different contributions? This is not the issue. The issue is one has to start somewhere. If you just look at fluctuations of the signal and say, I just take that as the uncertainty of my measurement, maybe add the calibration error as well, then I think you're doing fine. But if you ignore it at all, this is not good. Anyway, okay, I already indicated some of our consideration that we have done. In the end, we were just looking at two contributions, the calibration contribution and the fluctuations of the signal. And the reason why this is the case is that it appeared to us that the fluctuations can be very high, as I've shown on the slide before. And the calibration can also have, so to say, sets the lower limit of the uncertainty. And what you see on the graph here on the left-hand side is the expanded and combined uncertainty at a 95% level. That means 2 times the standard deviation taken from the fluctuations here. And this is shown as for temperature measurements for different sensors and also different conditions. And typically, if you see these major differences here between this sensor 5 and sensor 3 and sensor 1, it has something to do with the number of measurements that you are taking. So you probably know about the standard deviation of the mean. If you just have a few measurement values, you're not able to average out the statistical errors or the statistical uncertainties, and that means your expanded uncertainty goes up. So actually a very simple consideration. And there's another aspect I mentioned this already, this calibration uncertainty here, this dashed line sets a lower limit. So you cannot go beyond less than that. And this is about 3 millikelvin. So some people are claiming they can do better than 1 millikelvin. Again, temperature scale is not defined to that degree. So the stability can be like that, but not the accuracy or uncertainty in that case. So it's up to discussion. Maybe if you have different views on that, let's discuss it later.
Hey, Christoph,
Yeah.
can you hear me? Oh, great.
Yes. Yeah.
Yeah, no, I'm just looking at that graph, and the CTDs we're getting from Seabird, for example, I think they're in the 1 to 2 millikelvin range in terms of the accuracy on the data sheet.
Yeah.
And yeah, okay, so I've always kind of wondered what is the actual uncertainty. I knew it would be bigger, but here you're suggesting it varies quite a bit. In some cases, it's like, an order of magnitude more than the accuracy, let's say.
Yes.
And in other cases, it looks like it's actually very close to what you would, the data sheet accuracy. So
right.
I don't know if I have a question. It's more just a kind of a realization.
Okay, this has to do with the fluctuation part. This calibration, so to say, this dashed line, and then this U-square fluctuation, which is related here to these fluctuation of the signal that you see here. So we took a standard deviation over a certain time interval, 3 minutes, and then said, okay, this is a contribution to our overall uncertainty.
Okay.
Maybe it's too short, but
no, that makes sense. I guess it never occurred to me that the uncertainty might be changing kind of along the time series, and so this is an interesting sort of realization for me. Thanks.
Okay. Anyway, we can discuss that, and some people might have different views, and I know it's not that everyone immediately agrees. And so I must say, it took us 2 years to come up with the publication. And at some point I said, okay, I give up. I don't see any way to get agreement, but at least within the small group, we got some sort of agreement, let's say it that way. And maybe you have other ideas, or maybe also see some logical mistake that we made. But, I'm open for any type of discussion. And my feeling is this discussion is something that we have to go through. Otherwise we cannot make any progress. So thank you for your question. Okay, so another thing is with salinity, I just want to briefly talk about this. And so the range of calibration uncertainties for CTDs were even worse than I just show on temperature. And it's not a big surprise, but I think people are still dreaming that their salinity cells are better than 0.01 in accuracy or uncertainty, and I have my serious doubt. And you probably know that Argo CTDs are claiming, or the salinity data are claiming they have an accuracy or uncertainty, I think they use it synonymously, of 0.01. And I think one has to look carefully into that, whether they can really guarantee it. And everything that's better than that has an issue. I don't see how this could work. Even if you look at this data, there's some indication. You see these different markers. They give you an idea that here are different CTDs calibrated, and obviously at some conductivity values, they are far off. On the average, it looks quite nice, and I think what manufacturers specify is some sort of average value. But still, I think there's, so to say, systematic aspects, some systematic bias. It could happen that you are in a range where your CTD is not as good as you would ever expect. So it's just an indication. Maybe other people have other experience. It's just something that we were thinking about. Okay, here comes a very special effect that has something to do with that we're making measurements close to the seafloor. And these large fluctuations in this yellow data points coming from a CTD is related to sediment that goes into the conductivity cell. And what I can tell you is this was not a seabird. Just to make sure that you're not getting concerned. It can happen with seabird cells as well. And they are actually quite robust against sediments entering the conductivity cells. But there are other manufacturers who are using open cells, have different configurations, and they are not good at all for that type of measurements. On the other hand, this is just something that I heard. In profiling application, these open cells seem to perform better than the pump cells of seabird. But Anna, don't nail me down on that, okay? It might be just individual experience. Okay, so we took measurements over this time frame of 3 to 4 months, and actually we were quite impressed when we saw the first data coming in, and these are salinity data. And I must say I was quite happy to see this, that the spread is between these 4 CTDs that are shown here is just 0.014, to say. And actually we had expected something worse. And so that's, from our point of view, something that you can, so to say, is a limit of intercomparison experiment. You know, if you have done something similar, came to better results, just let me know. But that's what we found out. And that was something that we were hoping that is at the end of campaign will still prevail. And one sensor actually, not shown, was off by 0.05. So even though he was calibrated with all the other sensors at the same time, don't ask me what has happened to this. It shows that this conductivity measurements still have some issues, and that might be related also to the way how we handle it, the conductivity cell. Maybe we should have kept them wet. We let them dry out and then deployed it. Maybe that was the issue. So there's something to investigate here. Okay, at the end of the campaign.
Christoph, can I ask a question about that last
Sure.
one? Actually,
Yeah.
I've got lots of questions going back before, but I'll save them to the end. But
Okay.
on that last, this slide, how long were these instruments in the water before you took this particular measurement?
10 hours.
Pardon me?
10 hours, about 10
10
hours. So that was the first day. Mm-hmm.
Okay.
Okay, so
Thanks.
it was not some behavior, so that, you know, when you just put into the water that you have some effects like bubbles or anything. So that was already gone.
Flooding time, yeah.
Yeah. Okay, and that was at the end of the campaign in November. And just we had prevailed from our, actually we had 5 always in the water, and we had 6 instruments, and 1 was always replaced. So these 3 instruments seem to perform the best, and you would say, wait, you probably have to, you forgot to correct for drift behavior. I can tell you, we corrected for it. In other cases, it would even look worse. You know, and I know there's some people who have brilliant skills to even deal with that and say, we can get this variation between the different sensors further down. Maybe, but this was not our aim. We were trying to make everything so traceable, like we know what we were doing with the data at every instant in time. And so that's what we found out. I know people say this is not a good result. It may be related that we were in a coastal domain. Maybe something has to do with biofouling aspects. But, we were really trying to get a handle on that. By the way, cleaning the cells by divers had no effect at all. That was not something that was bringing any improvement. So because we have done this as well, and that was not very successful. Okay, this is something I'm coming close to the end of my presentation, and these are some future goals. I think all these topics that are related to what I just shown has to do with metrology. And many people will say, yes, sure, metrology principle or metrological principle. This is important to keep track of, and sure, we will apply it, but they just look into the calibration business, not in the field measurements. And I think that's something that is still missing. And so we try to contribute to this aspect, not sure to what degree is really helpful or can be used. Methodology principles I mentioned already. And what I also found out is I thought, the bottom-up approach, what we actually have done, is sometimes good, but then it takes a long time until other groups are adopting this approach. And then we thought maybe it's a good idea to talk to IOC and GOOS and get them involved. But you probably know they have this ocean best practice system established. That's it, The rest is we leave it up to you how to discuss this with the ocean best practice system. Everything else we are not interested in, which is a bit problematic because, the WMO, World Meteorological Organization, has a different view on that. And this is something that is currently discussed. And as soon as you talk about standards, standard operating procedures, again, you would say IOC or GOOS should have a role, but there's maybe they don't feel competent enough, or I don't know. It's interesting that they try to stay away from this topic. So some work that has to be done. Maybe I can skip that. No, just a final word on the guide to the expression of uncertainty of measurements and the international vocabulary. So this is the core of the metrology system. It's not just calibration, it's even each phase of a measurement, field measurements or calibration. For all that, you can apply the GAM. And we have done that. And in the end, I think it's fantastic. It's a very good concept. But to what degree you can actually use it in the ocean science or even in meteorology is up to discussion. So I think it has to be amended. And that's something that actually presented yesterday and carefully try to convince people, say, maybe we should at least talk about this, whether we should amend the GAM and maybe also introduce some additional vocabulary. But it's a long process, and in any case, but I'm not too pessimistic. Okay, this is my final slide, and you may have wondered on my first slide, where you see this nice picture of this glass of beer. Here at the end, here on the right-hand side, you see it's empty. That's also to do with my slides. This is all I have to say. I show you my conclusions, but I wanted to mention this is a bar that I often go with my buddy in Bremen. And if you come to Bremen, I will show you this bar as well. The beer is fantastic. Okay, anyway, so my conclusions, the gap between those that do the measurement, those that evaluate the data have to be closed. If you belong to the group of people that collect the data, I wonder how often you had a closer look at the data and said, okay, maybe I try to understand from my point of view what they mean. what this actually means. And I was in a situation, and I took the time. I actually lose the situation of pandemic, say, okay, now I have weeks and months to think about, and I've done that. I think I have now a different view on this aspect. Have a look at the data, think about QA/QC procedures, and so on. One major issue is separate instrumental environmental effects. And this is another reason why data producers and data users should come together. You know, often if something doesn't match the picture that a modeler has, then they said, there must be something wrong with the instrument. And if the so instruments operators say, no, everything is right, and then there's some sort of deadlock. It doesn't really help. And again, I think the metrology can build bridges here. I also think that there is a misunderstanding of what you actually measure. If you measure a temperature or salinity at a certain spot and at a certain time, what does it actually mean? It has to be in some sort of context, and the context is a time series. And then you say, okay, this is very interesting, but what does it mean for a neighboring point or at a different time? So that you can call it spatial-temporal correlation. Is this given, or is it something when I measure something at a certain spot, is it just specific for that spot, for a region, or for some global trend? And I think that's a very important question. Has to do with measurement strategy. And finally, uncertainty constraints should be given attention to feed measurement, should not just be assigned to calibration. Yeah, that's what I always repeat, but not sure whether maybe there are better ways to convey this message. But I think between us we can be very frank and open. Okay, that's all. Thank you very much for attention, and I'm happy to take your questions.
Thanks a lot, Christoph. I'm sure we've got a few. I know Tom said he had one. Do you want to kick off, Tom?
Yeah, I've got about 4 or 5 listed here, but
oh my God.
So yeah, first of all, Christoph, thank you for doing this. This is I find this stuff fascinating. Now, that's because I've designed CTDs, and I've also done testing of various manufacturers' CTDs as well. And so what you're doing here is I think very useful, and B, it's really cool for me. Couple of interesting things though. Rightly so, you didn't come out and name manufacturers and stuff, but with the cells that you were testing, which of them were closed cells, and how many were open cells, and how many were inductive cells?
None of them were inductive, but we had 3 seabirds, 3 closed cells, and 3 open cells. I think I believe one of the seabird was an open cell as well.
Okay. The reason I was asking that is because I was wondering how much electric field interaction might have played into this, because your separation was pretty close.
Yeah.
In these.
Okay.
I know, for example, on the AML sensor, it's it's an electrode sensor. It's not inductive, but there is an external field on that, and it goes out a few centimeters away.
Okay.
So, seabirds on the closed systems where they're in the tubes with the electrodes, the ground electrodes on either end. You don't have to worry about those, but.
Okay, that's something that I haven't thought about, but it's something I should maybe explore a little bit more detail, because this evaluation of the salinity data is still going on. So we have no final idea how to present that. So that's a very important advice for us.
Yeah, and
Thank you.
along that same note, it'd be interesting to check for the galvanic interaction between the cells. If all of these are electrode-based cells,
Yeah.
are they all galvanically isolated?
Yeah. I
I'll
cannot.
let somebody else ask questions now.
Okay, thank you very much.
Martin's got a question.
Yeah, actually, I also have several, but I start with the most fundamental one, which is the thing that we observe with our long time series as Ocean Networks Canada, where we do instrument changes on a regular basis just to get them ready for maintenance. And we do have jumps at the data when we come down with a newly calibrated instrument. So what's your recommendation on post-calibration and how to deal with these jumps where you put in the best instruments that you can find, best calibrated, and then you deploy a new one and you get a different result at the same site when you swap?
Not sure whether I 100% understood the jump. So what we saw is that you have a degradation due to biofouling, and that's sometimes obvious because we have these 4 or 5 different instruments in the water at the same time. But sometimes it's not that obvious. And so what we also have done is we took a water sample and then readjusted the salinity value. But then at some point it was drifting away again. So it was not that you have a very good handle on that. And Siebert is recommending to have a linear approach to that. You take the starting point, the end point, and then do a post calibration, and then you're adjusting linear, or you're doing a linear correction on that. So assuming that you have a linear effect in regard to drift. You're probably aware of that?
Yeah, that makes total sense. Thank you.
Okay, and that's something that I doubt. So it will not be linear over time. But that's something that it's a very difficult thing. And one more thing, finally, sorry if I bother you with that, is we have been thinking about doing a calibration at the end of our campaign. And I said, no, I'm against that. And people didn't understand. And I said, there's a lot of work, and we still don't really know what it actually will bring. Because if you take it out of the water, it will dry out, and then you clean it, put it into a calibration bed, and what does it say? It will have a limited statement. There's just limited insight to what happens in between. So the status while it's in the water and the status while it's back at the calibration bed, and that's this cleaning issue. Sorry.
It's great. Yeah. Thanks for that answer. Excellent.
Yeah, thanks, Martin. And we've got Bennett.
Hello, Christoph. Is my audio okay?
Yes, it's okay, Bennett.
Okay. Just to add to that previous point on the post-cruise calibrations offered by Seabird, actually with Eberhard Kopiski from MARUM and Jan Macron, we got in touch with Seabird and had already started similar thoughts. So I feel like I walked right into the correct meeting here. We learned that they do clean the CT cells before they do the post-cruise calibration. So that is the same thing that you're kind of alluding to, that the linear fit is a bit of a stretch to use these post-cruise calibrations. Yeah. No, great. So I will watch the recording. I think this is already the great group. I'm happy that I walked into this. So this is exactly what we need to do, I think.
Okay, great.
On that note, we ran a bunch of tests on several CTDs, and it was not linear. So it was like it would go along for 4 hours, no problem at all. Then the biofilm starts building up on the electrodes, and then it starts going off. And some electrodes are smooth, and some electrodes have powdered platinum, and it's different for everyone. What we did find is Seabird's poison worked pretty well, but the UV approach worked even better.
Oh, okay,
So,
interesting.
so the my preference at the moment is to run with the UV irradiated cells, but you have to be careful as well. When you had mentioned that you had divers going down and cleaning these cells, if you have a powdered platinum electrode, they can screw up your cal in a hurry if they touch that electrode. And if they're not touching the electrode, then they're not getting rid of the biofilm,
Exactly.
and so there's no point.
Definitely.
So that whole cleaning of the cell in situ is quite problematic. It depends a lot on the type of electrode that you have on your.
I fully agree.
Thanks, Tom. Ben, did you want to mention something?
Oh, I was just gonna say, Bennett's joining us from the ONC, one of the ONC meeting rooms. Which one is that? That's downstairs. Anyways, yeah, we didn't introduce Bennett, but he's one of our. Do you work with the data quality team there, Bennett? Can never remember.
That is my formal job description.
Right.
No,
So,
we met with a couple of people from MARUM before because they are PIs for some of the OOI instruments in a similar setting. So we looked into, we talked about TBT. We have very low signal amplitudes and drift on top of that. So we were trying to figure out optimal settings for our CTDs at the highly productive sites. So we had a bit of a dialogue. So I was wondering if we never intended to exclude anyone, but I was wondering if there's similar groups going on somewhere else, and I'm happy to kind of combine them. So that would be extremely helpful. It seems there's a lot of similar folks in this meeting.
Can give you some advice. There is a group here in Germany who was recently established, and if I could send you the name of the person who is involved in that as well. That's Philip Fischer, who is the leader of the diving group. So, Ben, if you like, I can send you this email address, and then just get in touch with him.
Okay, yeah, I can definitely facilitate that.
Okay, great.
Ben, you could probably introduce us, and then I can pass along that email to Christoph. And Martin, another question.
Yeah, sorry if I may. Although Tom, I thought had tons, but
I got lots more.
So just a quick question on any height recommendation above seafloor. You mentioned that you would have loved to be higher, but you had to choose 1 meter because of the current, and then you had this contamination.
Right. I can't tell you whether 2 meters wouldn't mean any problem at all, but I was actually thinking about 2 or 3 meters above the seafloor. But yes, and so if you look at data, you have another observatory as part of Ocean Network Canada. This coastal is called Venus. Yeah. Do you also have instruments close to the seafloor there?
Yeah,
you should look at the data, and you probably see this type of effect there as well. And so I also know of another observatory in Europe, this in Barcelona. They also have the same effect, and I told them, here, watch out, you're probably too close to the seafloor. We found out that there is a very good correlation between these effects and strong winds, and strong currents and waves and so on. So then they have some resuspension process started. So that there was a perfect correlation with that. So we are pretty sure that this has something to do with sediment.
Yeah, great question, Bennett. Maybe just because it's 1 o'clock, I'll give people a chance to say their goodbyes if they have to, and if folks want to hang around and continue doing some Q&A, I imagine Christoph won't mind.
No, I don't mind.
Cool. No, it looks like everyone's sticking around. Awesome. Any other questions? Tom, you said you had a few.
Yep. So one of the things was, your fluctuations. So when I tested a bunch of these CTDs, we found a lot of fluctuations in our data as well.
Yeah.
And we went to a lot of effort to try and figure out where those fluctuations were coming from. So we identified a number of different sources for these. One comes back to how close you are to the seafloor and the turbulent motion of the flow, because we have a lot of tidal currents where we've been operating, and so there's a lot of eddies that go through your instrument sampling area, and so that certainly was providing some variations from sensor to sensor. So on average, they were sort of okay, but you could see these fluctuations. And on the sensors that had a very fast response time, you could actually see those turbulent motions of water going through them. So the Seabird one averaged all that out, so the data kind of looked better, but in actuality, some of the sensors that had really high response times were probably more accurate. They were measuring what was going on in the water column at that site. Another one was we were trying to find a bias problem between, we would put these things in the calibration tank, the two instruments, different manufacturers were agreed bang on, but when we put them in the water, we found biases on them. One of the sources of those biases was the heat shed by the pressure case. And so that would, so whenever we had the pressure case below the sensor, we had these bias levels and more fluctuations. And if we turn the thing on its side so that we had clean water coming up through it and not contaminated by the heat of the instrument case, that certainly helped.
Interesting.
Yeah, there was, and there's also a lot of micro currents that we wound up looking at too, and so putting in some of the focal technologies used to have this what did they call it? It was a current meter, but it looked like a lacrosse net, and it had 12 different passes, and they did turbidity or vorticity on it, and it was great for micro turbulence. And so that kind of measurement was showing that there were these tiny little on the centimeter scale turbulences going through these sensors, and so that was accounting for some of the fluctuations that we were seeing on a sub-second sort of factor. So there's a massive amount of uncertainty that's actually real in the environment that you're measuring here. So
definitely,
it's a tough thing to look at. So response time of the sensor certainly needs to be in there.
Definitely.
Your comment about sediment was an interesting one too. We ran into a number of problems when we were testing between different manufacturers as well on cell orientation and how how that cell would fill up with sediment, because one of the things that ONC deals with, especially out around the Fraser River, is the amount of sedimentation is just unreal. Like you'll have a meter settle on your stuff in one tidal cycle when they're going through when the freshet comes down through the Fraser River. So that's a crazy area to try and operate a CTD in. And so again, orientation of your cell plays a big factor into its accuracy over time.
I agree.
Bennett.
So a follow-up question on the heating issue. We tried to mitigate biofouling at one of the offshore sites by reducing the sample rate, and we did that by switching from about 1 or 4 hertz profiling mode to what Seabird calls moored mode. So we'll just sort of put the instrument down for a while, then flushes, goes through a flushing cycle, then samples, draws the sample from an average and stores that. So now what we observed was that the pressure of that CTD dropped like a systematic bias by about 1 decibar. and the only way we could explain that was from heating. But then we kind of followed up a little bit with Seabird and thought about it. We couldn't explain that there would be a heat source hot enough to do that. But what Tom was just saying was that they observed something similar, unless I kind of understood that incorrectly. But yeah, has anyone
not
else
on
observed
pressure. So the heating that we were seeing was it was like a very small amount, but it was enough to throw off your calculation of salinity, because you had an error on the temperature sensor versus the C cell, because they're not co-located. But that shouldn't be affecting your pressure sensor.
Yeah, we've seen it both. Like we had an offset between so this instrument had an optode oxygen sensor with a temperature probe and a CT probe, and they would have also about a ½ degree difference that disappeared from our sampling mode change. So we knew something was apparently heating the oxygen optode, but again, like we wouldn't know what. Like there's just nothing there that is running that hot. But apparently, maybe these sensors are internally so sensitive to small changes in heat. Like on the
Well, they are. I mean, the TEOS 10 with the accuracies that Christoph was presenting here, it doesn't take much to push you away or outside of those uncertainties. The thing to look for in your sensors is most sensor designers will opt for a linear power supply, or your voltage regulator, because they're a much cleaner supply and it contaminates your sensor reading much less. But they generate a lot of heat. You know, if you're using a switching power supply, they're much more efficient. They don't generate as much heat, but they generate a hell of a lot more electrical noise into your sensor. So there's good and bad with both cases.
We can't hear you, Dustin.
Oh yeah, sorry guys. Yeah, any more questions? Time for one more, a lightning round here.
Maybe what was the variation in your response time of the sensors that you were testing?
For the temperature sensors, we had a Seabird, which is specified in the second range, and we had another manufacturer, German manufacturer, which is specified in the sub-second range somewhere. I think their sample was 10 seconds, but I think it's maybe half a second or so response time.
Cool, guys. Well, Christoph, thanks so much for this, and definitely looking forward to some of the other papers that are coming out around this topic. If anyone has any more questions, Christoph is also on our Slack channel, so you can kind of hit him up there.
Okay. Thank you very much for your interest and for the nice discussions. It was very helpful. I hope I can join you again some other time. And yeah.
Are your papers going to be linked here somewhere?
They are in the Slack meeting announcement, and I think they might be in email as well, but I'll double check. There should be a link embedded in the paragraph there, Tom.
Okay, thank you. Yeah.
I have 2 oceans paper, 2 presentations from last year as well. Maybe I can add this.
Absolutely, yeah.
Okay.
Yeah, that'd be great.
All right, guys. Well, we will say, oh, and Bennett's just giving you his email address too.
Good. Perfect. Thank you.
Awesome, everyone. Well, good convo, great presentation, and hope to see everyone again soon.
Yes, thank you very much.
That was great. Thank you.
Bye-bye.
Much enjoyed that. Take care, everyone.
Bye-bye.